All right, so we just go ahead and watched the last video. You saw how they made double angle identities from the addition and subtraction formulas. We're just going to go ahead and use those. The sine of 2 times theta is equal to twice the sine of theta cosine of theta. The cosine of 2 theta, we actually have several of them. We have 3 of them, as a matter of fact, is equal to the cosine squared of theta minus the sine squared of theta. It's also equal to 1 minus 2 times the sine squared of theta. And the last one is 2 times cosine squared of theta minus 1. You can use any of those for the cosine. And then the tangent of 2 theta is equal to 2 times the tangent of theta all over 1 minus the tangent squared of theta. All right, what we're going to do with these today is we're going to go ahead and find exact value of some trig functions. So in order for us to do this, we need to go ahead and remember a little bit of what we did in the very beginning of the semester. So if we go ahead and start with my given statement that the sine of theta is equal to 3 over 5, and we are only interested in the angle between 2 pi, where theta is, and between pi. So what this tells us to remember is that this is your angle between 2 pi, pi over 2 and pi. Probably said that wrong over here. Again, my interval is only between pi over 2 and pi. So we're going to go ahead and draw my triangle in here. Recall that the sine of any angle is equal to the opposite over the hypotenuse, and that the sine of, in this case, when you're having a ratio, that is going to be your y value over the hypotenuse of the triangle that we draw in. So we have this hypotenuse that we know is 5. I know my y value here is 3, and that's because of what we just said, that we have this fraction that is equal to 3 over 5. Now, we use the Pythagorean theorem to find out the x value. So I have that x squared plus y squared is equal to the hypotenuse squared. X squared plus 9 is equal to 25. X squared is equal to 16, and x is equal to 4. Now, note when we go through and put this in, x is 4, but in this case it is a negative 4, and that is because this is in quadrant 2. So my y value is definitely positive. The 5 is positive, but my x value in this case, because it's in the second quadrant, is negative. It's going to be really important here in a second. So I'm going to go through and make this a little bit smaller so we can go ahead and work on the first question that I have for us today, which is find the sine of 2 theta. Well, the sine of 2 theta, from the formulas I just wrote from above, is equal to 2 times the sine of theta times the cosine of theta. So the sine of theta we were already given. The sine of theta was just 3 over 5. That was given to us in our question. The cosine, though, what is the cosine equal to? Cosine of theta is equal to the adjacent over the hypotenuse. And if we remember our mnemonic for all of the sines of the trig functions, we know that all functions are positive in the first quadrant. The sine is positive in the second. The tangent is positive in the third. and the cosine is positive in the fourth quadrant. And the mnemonic is all students take cash. That's what we used in class. So the cosine is my negative 4 over 5. So this value here, the sine of 2 theta is just equal to negative 24 over 25. All right, so I just copied my triangle back down over, and now we're going to do the same thing. But now this time the question is going to ask you, I'm going to ask you is what is, for this question, what is the cosine of 2 theta? All right, so for this one, we're going to go ahead. Doesn't matter which one of these we use. We can use any of the formulas. I'm going to go ahead and choose to use the fact that this is equal to the cosine squared of theta minus the sine squared of theta. Now we found those two values above, the cosine of theta that we just did begin, that this was the cosine, this was the sine. So my cosine squared is negative 4 over 5 squared minus the sine, which was 3 over 5 squared, which gives us, when you square a fraction, it's just the numerator squared over the denominator squared. So that's 16 over 25 minus 9 over 25, which gives us 7 over 25. You can go and use the other two formulas for the cosine of 2 theta, and you'll get the same value. All right, we're going to do this one last time. This time we're going to go ahead and go through, and let me just get this out of the way. Push that up there. We're going to do this one more time, but now we're going to go ahead and do this for the tangent of 2 theta. And the tangent of 2 theta is 2 times the tangent of theta all over 1 minus the tangent squared of theta. Now, to find tangent, the tangent of any angle is equal to the opposite over the adjacent. So I'm coming back over here at my picture, and again, this is my angle that I'm looking at. So the opposite over the adjacent here is just 3 over negative 4. I always tell people to make sure that when you're doing the triangles, you put the plus and minus signs in the triangle. It helps make us sure that we remember that we're using the correct values when you're doing this. So to plug this in, I just have 2 times the tangent of theta, which is negative 3 over 4, all over 1 minus that tangent squared, negative 3 over 4. 2 times negative 3 over 4, that just gives me my negative, here. This 2 is understood to be over 1, so what I'm getting here is that's going to be negative 6 over 4. All divided by 1. Forgot to put that squared there, so that's going to be 1 minus, that becomes 9 over 16. All right, so how do I simplify this? 6 over 4, they both reduce by 2, and I am left with negative 3 over 2 in the numerator. In the denominator, I have 1 minus 9 over 16. I'm going to go ahead and combine those two fractions first to make that 16 over 16. So now I still have negative 3 over 2 in the numerator. In the denominator, I have 7 over 16. So this is one of those where it is, I want to turn this division piece into multiplication. It's my fractions. I'm going to keep flip that. So I have negative 3 over 2 times 16 over 7. And I'm left with negative 24 over 7. So those are two ways that we can go ahead and use the double angle formulas.